Hello everybody. In this video, we will prove the following reduction formula, where the integration of the bracket x square plus a square power n dx is equal to 1 over 2n plus 1 times x times the bracket x square plus a square power n plus 2n a square over 2n plus 1 times the integration of the bracket x square plus a square power n minus 1 with respect to dx. So you can solve this problem using several approaches. Uh, you can use one by applying the integration by parts here, by considering this. If you this would be the part to be differentiated, and the part to be integrated is the 1 dx. You can use this approach to solve this problem. Another approach, which I will encounter right now, is to split this into integral, or this bracket specifically, into x square plus a square power n minus 1, where we will multiply by x square plus a square. This is the left hand side, as you can see. So you can distribute this bracket, so you will get the integration of x square times x square plus a square power n minus 1 dx plus the integration of a square times the bracket x square plus a square power n minus 1 dx. So we will try to integrate this by using integration by parts, where this integral would be considered to be x times the bracket x square plus a square power n minus 1 plus the other integration, which is a square times the integral of x square plus a square power n minus 1 dx. So if we used integration by parts here, you can integrate this part easily, so you can call it dv, and this part will be u. And as you can see, I chose the x to be among the dv because the differentiation of the function inside the bracket is 2x, so we are missing a 2 here, and we can remove it again by multiplying by half. So half multiply this integration by parts. Using the integration by parts would be uv, the integration of this, which would be x square plus a square power n over n over the new power. This is the v, so it will be multiplied by x also, which is the u, minus the integral of you know the rule of integration by parts, that it is uv minus integration v du. So here is the u, here is the v, minus integration v, which is x square plus a square power n over n, v du, the integration of, or the differentiation of x, which is dx, the differential. So this would be plus a square times this integral. If you can see, this integral is very similar to the first integral. The first integral, we can call it in, where n is the power. So this would be in minus 1. So I will try to simplify it here to be in minus 1. You can see here also that if we remove this n and put it outside, this would be in. And the left hand side, which is all these equalities, is in. As you can see, here it is, this is in. So in is equal to what? It is equal to this, and I will distribute the half. So x squared plus a squared power n over 2n times x minus 1 over 2n, and this whole part is in, plus a squared in minus 1. As you can see, the problem is much easier now. It is only a matter of simplifying. So I will add the in's with each other. So 1 plus 1 over 2n, which is equal to x squared plus a squared power n times x over 2n plus a squared in minus 1. I will take that and divide it in the other side. So, and this is also, you can simplify to be 2n plus 1, or to put it in another form, this is the same by making common denominators. So in is equal to what? We will reciprocate this fraction to be multiplied by this whole term. So x squared plus a squared power n times x over what? You can see that the 2n will be cancelled with the 2n. So we will have here 2n plus 1 plus a squared times what? Times 2n divided by 2n plus 1 times in minus 1. You can now compare it with the right hand side in the proof. So in is equal to 1 over 2n plus 1 times x times the bracket x squared plus a squared power n plus 2n a squared over 2n plus 1, and this integral, which is in minus 1, can be written as x squared plus a squared power n minus 1 with respect to dx, and the in which is the first integral, or the left hand side, which is the integral of x squared plus a squared power n dx, and it is equal to the right hand side. If you have any questions, you can comment, and please try to solve it with yourself before watching the full solution. And if you stopped at anything, you can write in the comments so that I can help you. And see you again in another video.